We are done with our tree-based model. Now we are going to go into other models. One of the popular model we use is the support vector machine. In the machine learning, supervised learning, support vector machine, SVM. So support vector machine finds a hyperplane that best separates the two classes. The hyperplane maximizes distance between two classes. The hyperplane maximizes the distance between two classes. So if you are looking at see, the red line is the hyperplane. The red line is the hyperplane with an equation w into x minus b is equal to 0. So the red line is the hyperplane that separates the classes, that separate both the classes. And it draws the hyperplane in such a way that it maximizes the distances between the two classes or the margin between two classes. It also draws two support vectors touching the closest point to the hyperplane so it draws two support vectors. The dotted lines are drawn that touch the closest points close to the hyperplane. These two blue dots are closer to the hyperplane. So a dotted line, also called a support vector, is drawn touching these 2 points. Here the green is the closest to the hyperplane. So a support vector, a dotted line is drawn. So the equation for this line is W into X. Weight vector into X minus B is equal to 1. Weight vector into X minus B is equal to minus 1. The classification criteria 1 and minus 1. And the margin between these two is 2 by magnitude of W. This is all vector arithmetic. Support vector machines uses vector arithmetic. Support vector machines use vector calculus or vector arithmetic. Particularly the dot product. What is the formula for dot product? Dot product formula. Yes. Dot product of A into B is equal to magnitude of A multiplied by magnitude of B into cos theta, or cos theta is equal to A into B divided by magnitude of A by magnitude of B. Magnitude of A means A square. Magnitude of B means B square. So this is the vector arithmetic which is used in support vector machines. The dot products are wide. Dot product is used in calculating the values or the distances between the existing point and the proposed point. So vector A into vector B is equal to magnitude of A into magnitude of B into cos theta. If the magnitude of B is 1, then C is equal to vector A into vector B, which is equal to magnitude of A into cos theta. So it is all about vector mathematics and vector calculus, which is widely used in your support vector machines. It is all based on vector calculus. It is based on vector mathematics and vector calculus. So the margin is the agenda is maximize the margin. The margin of separation should be the biggest. It will try to see a line can be drawn in any way. You can draw the line like this. You can draw it like this. You can draw a straight line separating them in any way. A lot of ways are there, but it draws a straight line such that the margin between the two classes or the separation between the two classes is the widest or the maximum. That is the fundamental of support vector machine. The margin is very, very important. And two support vectors are drawn touching the closest observations on the either side of the margin or the hyperplane. Now, there are two types of support vectors, linear SVM and non-linear SVM. There are two types of support vectors that we generally use. Linear SVM and non-linear SVM. So for linear data, we have linear SVM. For non-linear data, we have non-linear SVM. Okay. So support vector machines are very useful in natural language processing, image processing, because they tend to separate the classes very, very distinctly or very, very clearly. Now, one of the problem for support vector machines is when the classes are very, very close to one another, or there is a overlapping in the case of the observations. If there is an overlapping of what you call observations, then support vector machines need some additional support. That we call it as kernel tricks. Kernel trick is very important in support vector machine, because when your data is clearly separatable, then there is no problem. When it is non-linear, non-linear means overlapping data points are there. So let me show you what this non-linear looks like. So linear data versus non-linear data. So this is your linear data problem, where you can draw a straight line easily to separate the classes. This is your non-linear problem, where you cannot draw a straight line to separate the classes. And most of the time, the real-time data will be non-linear in nature. Linear data is again a hypothetical situation. Very rarely you will see linearly separated data. Non-linear data means the data will be fuzzy, overlapped, and clustered. Fuzzy, overlap, and clustered. You can't draw a straight line. Sometimes you have to draw it like this. Or in some instances, it might be a line like this. See, this is your non-linear model. Something not like exactly this one. These two are linear models. As long as you can separate them very distinctly, we call it as linear model. But when you can't draw a straight line, then it becomes a non-linear. Some textbooks classify this also as non-linear, but in machine learning, when you can separate a line with a kink, there is a bend here, but still you are able to separate the classes. Still, we can consider this as a linear data. But when you have this scenario like this becomes a non-linear data. When you have this non-linear data, you have to convert it into a linear data. Why? Why do you need to convert the non-linear data to linear data? There in the graph. Because support vector machine uses straight line equations. What is yx plus b and yx minus b? Mx plus c is straight line, right? So you can see here, support vector machines try to use a straight line mechanism or a linear mechanism. So these kernel tricks will transform the data from non-linear to a high dimensional space where the algorithm can use linear separation methods. The kernel tricks will convert non-linear data to a higher dimension data, or to high dimension data, such that SVM algorithm can clearly draw a hyperplane that separates the classes. So the kernel tricks are very important, particularly when you're dealing with non-linear data. So what this basically this kernel will do is see, once you apply the kernel, it becomes a high dimensional data where you can draw a linearly separable decision space. This is your actual nonlinear data. By applying a kernel, it transforms into a higher dimensional data where you can draw a decision surface or a hyperplane very, very clearly. So this is the job of the kernel trick. The kernel trick will convert the data into a higher dimensional space where a clear decision boundary can be written. These are straight lines, right? These are linear separable decision boundaries that can be easily, we can draw the separator very, very easily. The most popular kernel which is used is the radial basis function. The most popular kernel trait which is used is RBF or radial basis function. One of the most popular thing is the RBF kernel, which is default kernel in your what you call more Python and all the other. So the kernel will transform it into a 3D hyperspace like this. The Gaussian RBF kernel. The Gaussian RBF kernel is a very, very popular kernel that transforms the two-dimensional space into a three-dimensional space so that you can draw a linearly separable hyperplane that distinctly classifies both the classes. So RBF function or radial basis function. So the Gaussian radial basis function shifts the point from a 2D plane to a 3D plane by just shifting by using a RBF Gaussian So it shifts all points using a mapping function called the Gaussian RBF function, which introduces a hyperplane in the given space. The Gaussian RBF function will do this process. This is what the Gaussian RBF will do. And the formula is this. The formula for Gaussian arbiters is exponential e to the power of minus magnitude of x vector minus li vector square 2 by 2 sigma square. So there are other kernels called sigmoid kernel, polynomial kernels are there, but the most used is RBF because it is highly effective in doing it. There is sigmoid kernel also. There is a polynomial kernel, but they are very rarely used. But see, now how to decide whether to use a linear kernel or a non-linear kernel like RBF depends on the type of data you are dealing with. When you do a scatter plot of your dependent variable of zeros and ones, if they are linearly separable, then there is no problem. But if they are not linearly separable, if they are very close to one another, then we have a issue. That issue is, or then we have to start using the RBF kernel. So whenever you run the support vector machines, if your data is very large, when I say very large, greater than 5,000 observations, we always by default go with RBF kernel. If it is a smaller data set, less than 5,000, where there can be linear separability of observations, we tend to use linear SVM. Linear SVM can be used on small data sets. But if your data set is very large, greater than 5,000 observations, it is always better to go with RBF kernel. That gives you a clear decision boundary, which helps us to classify better, and the accuracy of the model will also be increasing. Second thing is, SVM works for both classification and regression models, but its effectiveness as a regression model is not good. You can use SVM for both regression as well as for classification, but the performance of SVM in case of regression models is not good. Predominantly, SVM is used for classification modeling. It is one of the preferred models in image processing before the deep learning algorithms have come into picture. So support vector machines are very good in classification. Particularly when you have non-linear large-scale data, they tend to perform well on your data. So SVM, the RBF kernel must be used when you have large-scale data points. All right. So support vector machines is a very popular algorithm which uses vector arithmetic and vector calculus for classification problems, predominantly classification problems. Predominantly classification problems. And it has a very good performance on large scale data also. And the requirement for computing power is also minimal. So here, support vector machines in SQL and Python. So they are used for classification, regressions, and outlier detection. It's not outlier detection, it is more of anomaly detection. Outlier detection, anomaly detection we use in frauds. Fraud detection, we use this support vector machine, and we also use it in web anomalies. Why suddenly the web traffic increased? Why suddenly it fell down? Whether it is because of any attack or anything like that. So that is called outlier detection or anomaly detection. So support vector machine are very effective in high dimensional spaces. So SVM for classification, you have these methods: SVC, NUSVC, and linear SVC are classified binary as well as multi-class classification. That means more than two also you can do using these classifications. Not only 2 levels, it can do with 3 levels. SVC and USVC are similar, but what you call linear SVC is different. The basic is your SVC, support vector classifier, and the kernel by default is RBF. Kernel by default is RBF. You can see a C support vector classification. You have the polynomial, sigmoid, and linear also is there, but the default is radial basis function, RBF. Does that also give you?
I mean, like the previous algorithms like you got the value of accuracy.
Accuracy will come for all classification algorithm. For all classification, the metric is accuracy. You will get the accuracy. They are completely different methods. No? Tree-based algorithms are based on Gini and entropy. Gini and entropy are probabilistic methods, right? You use probability to calculate them. See, regression is a matrix formulation. We use matrix mathematics there to calculate the coefficients and do it. Binary logistic regression is also similar. Tree-based models also all use probability methods, which is Gini and entropy. Use probability, right? There we calculate the probability, and we use the probability for calculations. Support vector machine uses vector calculus and vector arithmetic. The fundamental what you call the fundamental mathematics of the algorithm itself here are completely different. So support vector machines are purely based on vector mathematics. So one is based on probabilities, Gini and entropy is based on basic probabilities. And this is based on vector calculus and vector arithmetic. So the mathematics itself is completely different. The area of mathematics is itself completely different. So these algorithms have different mathematical formulations behind. They are not all same. So that is why their performance also differs in bigger way. Like if the dimensionality of the data is very high, support vector obviously will be very, very interesting. When you have high dimensional data, when you have too many variables in your data, when you have hundreds of variables, your dimensions are going to be big, then you have to use SVM. Decision trees also work on high dimensional data. They also use probabilistic methods to calculate the Ginis and entropies and do it. In case of decision trees, you get variable importance. Here you will not get any variable importance. SVMs will not give you any variable importance. It's a simple classification algorithm. It simply says this belongs to this category, this belongs to this category. That's all it will simply say. No feature importance is given, nothing is given. Simple, it's a simple classification algorithm. It can also be used in regression models, but their performance will be very, very bad in regression models. Okay. So SVMs are widely used earlier in image processing, because image processing is high dimensional nonlinear data. They used to do, even today, they do very good job. 80 to 90% accuracy they give in your image processing data. But since the people wanted even bigger, higher accuracies, they went into deep learning and convolution neural networks, where the accuracies go beyond 90%. But if you don't want to use a deep learning or an advanced mathematical model, you can stick with a basic support vector classifier. If it is a binary classifier, it works very well. If it is a 3-class or 5-class classifier also, it works well, but more than 5 classes, it has a problem. The accuracy levels tend to decrease. Take, for example, you are classifying based on handwriting, what digit the person has written. 0 to 9 digits, right? 10 digits means 10 classifications have to be predicted. So based on the handwritten images, you have to find out what is the digit the person is writing. So in that case, SVM will have slightly bad performance in predicting some of the numbers. So that is where it lacks. But if the data and dimensionality is clearly given, then it will perform well. Okay. So the mathematics itself is different behind these algorithms. Till now, what we are doing, see, all the algorithms will have different mathematical orientations and mathematical calculations. Now, we have to understand the mathematics behind it. If at all you're changing the algorithm, if you are simply using the algorithm, a basic knowledge of algorithm is required, because if it doesn't fit well, then you need to answer why it did fit well. Because low dimensions or dimensions, margins cannot be drawn clearly, that you can say that for that reason only we are introducing the clear. Tomorrow, if the algorithm does not work well, your client will ask you why it did not work well. You can say the decision boundaries cannot be drawn linearly, clearly cannot be drawn. So that is where the algorithm failed. If the algorithm can draw the linear separators clearly, it will give you very, very good accuracy. Okay, so the mathematics itself is different behind these algorithms. So if it is a grouping algorithm like tree-based algorithms, RF, GBM, and decision tree, they are all tree-based. They all have the same Gini entropy and information gain as the basis, which is a probability-based method. That's a grouping of algorithms, tree-based algorithms. But each one has a different process of performance. The underlying concept is same, but the methodology again is different. One uses parallel processing, the other uses sequential processing. Random forest is parallel. Gradient boosting is sequential. So these basic and methodologies also differ in the grouping of the algorithms. Okay. So this is the theoretical background of support vector machines. So we will apply this on our analytics with the HR analytics data. Okay, so that we can do a comparative analysis how it performed. Analytics with the notebook, all of you can open, run all the cells, and kindly run the what you call HR analytics model, run all the cells. We will implement support vector machine. Once you are run, please tell, we'll run it. All right, done, all of you run it. So from sklearn dot svm import sv svm is equal to svc. We are keeping the default model as RBF. Sorry, default kernel as RBF, and the C value is 1.0. The smaller the C value, the larger the what you call hyperplane margin. The smaller the C value, the larger the hyperplane margin. The larger the C value, sorry, the smaller the C value. Hyperplane. So by default, C value is 1.0. So you can make it as C is equal to 0.80. Default is 1. Default is 1. SVM model is equal to SVM dot fit x comma y. It's running for all of you. So SVM model dot core x comma y. .48 accuracy. So SVM predict is equal to SVM model predict HR test TF. e dot data frame SVM credit CSV SVM dot CSV. You will submit on the competition site and check your score. Submitted, anybody? How much score you got? 0.0 on competition site. That is fully accurate. What is the rank? Ah. No, you submitted this, no, SVM. What was the score you got? Got it, all of you? Hey, just check your LMS, whether you got access to it or not. got access in LMS. So for support vector measure, what are the data set given? What is the model you got, data you got there? LMS. Okay. Practice exercises, just check. Any other data set is there? Just check any other data set is there in that LMS. Because you have to complete those LMSs also. So any other data set you got? No, right? So this is all about your support vector machine. What is the best rank you got in analytics, Sujay? That HRS, huh? 547, huh? 147. Good, that's a good rank. 1470 after submitting all models. Okay. What is the score you got?
For data industry was around 0.48.
Ah,
For XT was around 0.47.
ah,
And STM is like 0.
ah,
Leaderboard it says its rank is 147.
1470. Zero means the model is failing. It is not able to predict. So the problem is imbalance. Actually, we have to discuss uh, y dot value of count. See, there is a huge bias towards zero. Very few ones are there. This is a classic example of imbalanced data. Imbalanced data means there is complete bias towards one class, which is zero class. There is a minor majority class is 50,140, minority class is 4,668. When you have imbalanced data, we should balance it out. So what we will do is once we complete the algorithms, we will learn the imbalance techniques, the oversampling techniques and the undersampling techniques, and we will run the same algorithms and then we will see how the scores change. For once you do the sampling, what you call oversampling means by making 4,668 equal to 50,140 by creating artificial data or copy pasting the existing data, you can balance the data. And once you balance the data, then we can build a model and then see the performance. That is what we will tend to do. So support vector machines, yeah, SVMs are affected by imbalanced. Because what happens is the overlap will be very big, right? This is very small, that is a very class. When you put a thing, the dimensionality is very large here. In the term that, one class dominates the other class by, so it has a bias towards the larger class. So that bias is affecting our model. So that's why we are getting that error, 0. So in LMS, you don't have any so, hey, any other data sets, just check your data sets in LMS. Something you have to do now. Otherwise, welcome. Practice exercise, something will be there in LMS. he has not come. They have to assign it from Bombay, it seems, so I've been sending them. Yeah. Well, so for bike sharing data set, what about others? I got from what you call Vikram, Ashish and Harshita. What about other guys? You two guys and you, Rohit? You send it? I want you guys to complete this. You have run only one model, right? Regression model on this, right? Bike sharing data set. I want you to run decision tree. Run, right? So run random forest, gradient boosting, and support vector regression on it. The rest of the guys you submit it because I have to send it to them for evaluation. Okay. You have any doubts, you can clarify with me. Online also, online guys, you are there?
Yes, sir.
This bicycle sharing data set, you have done that assignment? Please complete it and send it by today because we have to give it to the, I have to send it to the governance and the team here. Okay?
Okay.
You work on it right now. Online guys, bicycle sharing data set. You guys who have completed, please run the other models also and submit the file, okay? Random forest and support vector regression, SVR. Tomorrow we will discuss name bias. SVR, na, which one is? So what it is, how much R square? So it's a failed model. I told you, it doesn't work well on regression.